Hi there, my name is Austin Dial. This is for EC 103, assignment number 8. It is Sunday, March 27th at about 10:24 p.m. I realize that this is several days late. Going on the record, this is several days late, but nonetheless, this is my code. Started writing it today, finished it today. Took about 4 hours, but man, it's a blast, and it actually goes above and beyond the requirements. Not to make you nervous or anything, but let's just go ahead and take a look here. So let's close this function. Okay, so just looking at int main, I added a verbose mode on here, which I'm known to do in a lot of my programs. Hope that the image resolution is good enough for you to see this. If not, you won't be listening to this because I'll have recorded another one. But either way, I hope that it works out. So the verbose mode allows for the debugging to be on, which will allow us to do a lot of cool, spooky dooky things. I'll explain all of these things later. Now the first part of the actual main program looks very familiar. It's the exact same thing as was provided in the actual main code that was given to us under the assign 8 folder. So my code actually begins here, besides the functions that I declared earlier. So, first off, what I wanted was the student's record system to take arguments. I wanted it to take arguments just like int main does. So for instance, I can say int main verbose, and it knows what that means. So I wanted the record system to be able to take, say, sort last, and then understand that that meant to sort the records by the last name. So I created a structure following in suit with the idea that this is about demonstrating what you know about structures. And I have to say, I actually really am proud of this workaround. It really is pretty effing cool. So I created struct word, and the word has characters, and I created 2 words, so 2 commands. And I simply recorded from scanf using 19 as a parameter of the actual format %s. That way I didn't overflow the characters within the actual structure, which I learned online, and I think it's really cool because otherwise you could easily create some sort of buffer overflow. So then I simply sorted into, under words, word 1, word 2, and then interpreted them from there using string compare. And that worked beautifully, and it allowed for me to store the actual strings and to even send them as parameters. For instance, you'll see later that when I define search, I actually just threw in the actual word itself instead of just typing in a string literal. And that came really in handy, and it allowed for me to create this hierarchy. So if the first argument is sort, then it will check, well, what do you want to sort by? Last name, first name, or ID? And from there, it will send either to sort last, which is a function, and then print, or sort first, and then print, or sort ID, and then print. There's a fall through here which analyzes the actual second argument. So if I say sort by grade point, well, we didn't program that. What that means is it will say invalid input 1. That means invalid input under argument 1, which, counting as a normal person, would be argument 2, 0, 1. That might not be extremely user-friendly, but it works, and I like it. Oh, I just added a W in there. Wouldn't want to do that. Wouldn't starts with a W. Never mind, I'm a pun freak. Anyways, so the next if-else here checks again for argument 0, which would be the first argument that the users put in, and it says, well, what if that's search? So the user can search. From there, it will actually go into the search function, which I'll demonstrate later, and then it will find out what you want to search by. I even found a paradox there that required the use of recursion, and that was really exciting. Now the third option is print, where it just prints the actual records as is. And in case the users want to exit, they can type in exit, and it will do just that. I have another fall through here where if just as I said, invalid input on argument 1, which would be 2, I also have an invalid input 0. So instead of if they say, not search, not print, not exit, nor sort, if they just say, add record, that's not going to work. And there you go. So now we can actually go up to the functions themselves. The print function might look familiar, because it is. It's from the original main that was given to us in the folder. Originally, under that, they simply printed the actual structure, all of the entries in the structure. Within the main, I decided to make it its own function. That way I can call it and control it. Then you can also see that there's a sort last function, a sort first function, and a sort ID function. All of them can be called, and they basically follow the exact same structure, so I could have combined them all. But I noticed in the notes, when he wanted us to combine them, it would simply check, if you want to sort by ID, run this one. If you want to sort by, and I figured, well, that's basically the same thing. It's just an if, else if, else if, else conditional structure under sort. I may as well just design that under a higher hierarchy, meaning I create 3 different functions instead of 3 different controls within the same function. So they're effectively the same thing. Now the last one was search, and that's what I'm really excited about. So if they search, then there's actually a search parameter in there, you might notice, char param. So what does that char param actually do, you might be thinking? Well, hang on here. So it sends the first argument, or second technically, because it's input 1. So it sends the second argument. So if you say search name, it will send name as an argument to search. Same if you search last or search ID. So it takes that and it simply says, well, if the parameter is equal to first, then we're going to search by first name. If it's equal to last, search by last name. If it's equal to ID, search by ID. So, similarly, I could have created 3 different functions for it, but I decided this time, unlike the sort, that I just wanted to have it all under search. And that will become apparent in just a minute here, because, for instance, if you want to search by last name, or pardon me, first name, well, there are multiple Johns and there are multiple Adams in the class, which means that if you actually search by first name John, well, which record does it choose? So it gives an error here, multiple Johns exist. Please enter a last name. Now, how's it going to do that exactly? Is it going to exit here and go to last? No. Instead, it creates a new parameter called param x, and x equals last. So it says, multiple Johns exist, please enter a last name. Now, none of the last names are the same, which means technically, if they're going to enter a last name to distinguish between 2 Johns, they may as well have just entered a last name to distinguish between anyone. So it calls the actual function search within search again with the argument last name. So it makes it look like you're searching for first name and then choosing between 1 or 2 Johns, but in reality, it's just looking by last name again. And then as soon as it returns for the first iteration of search, it exits with a value of 1 immediately. Now the same applies, of course, to Adam, because there are multiple Adams in the class, and it just follows the same recursive structure. And then I always provide an else, even if it's no need for action, because I just like to get in the habit of fall-throughs, even if they're not extremely necessary. Now let's look through how it actually searches. So it has string compare, first name, search value. This is an easy example here. So let's say that they're going to search by first name, and they're going to search for me. Austin, A-U-S-T-I-N. So they type in Austin. If it's lowercase, that's not going to work. If it's capitalized, it'll throw you an error. If it's capitalized, perfect. So it sends it through, and it says, while the actual value that it's looking at, using an iteration counter I, so this could be a for loop, but I chose against it. You'll see why. While the element or entry.firstname I does not equal the search value Austin, do everything inside this. And all that it really does is it just counts up with I plus plus, I plus plus, I plus plus. And say that you're looking for somebody by the name of like Hannibal Lecter. So you type in Hannibal, Hannibal doesn't exist, but of course it doesn't know that yet, so it continues down the code anyway, keeps going through here, and eventually when it realizes by this code right here that, hey, there is no Hannibal Lecter, as in Hannibal does not exist because after 46 iterations, which there are only 46 elements, we still can't find Hannibal. Well, then it will simply say the record you've searched for does not exist, and it will exit again with an error. This was actually a little bit tricky before I had this outside the loop, and it was an infinite loop. It would just continue looking for, oh, is record 9,000 Hannibal? Well, there aren't 9,000 records, there are only 46. So I threw this in here, and it's just kind of a breakpoint for it. Only you don't just want it to break, you want it to actually exit the program, because the search query doesn't make sense, so it exits there. Now once it finds I, let's say that it is looking for Austin, and let's say that I'm record 10. So it exits holding the record 10 in I, and then it simply prints the record I. Now last name works the exact same way. All the last names are the same from what I could see, so there's no need to do the whole recursion that we saw last time. And ID is really easy. It simply asks which ID, passes it to I, and then I just copy and pasted the exact same thing from the previous entry. Just print I, which is perfect. And there are a lot of fall-throughs in this. I like to be very secure in my code. I like to make sure that if the user enters something really immature or something that just doesn't make sense, it's not going to actually try and compute whatever that is. So that's that. We can see that it's pretty cool, but let's actually make sure that it works. Let's pull up terminal here. So I instead of using the whole file that he gave us under assign 8, I used the code from main, and I just took the data .text, and I actually renamed it data. Before, I think it was data entries or something, and I just didn't want to type that. Even though you have to type it twice, call me lazy. I just thought it's easy for me to refer to in my mind as data. So I put it in its own folder, wrote my own C program. I didn't call it main. I always called them A8. That way I can distinguish between them. Otherwise, when I say open file and they're all named main, I don't want to have to check the directories to find out what it is. So there are only really 3 files here: the executable, the C code, and the data.txt file, which makes it really easy because I'm using Notepad++ and just the CC compiler. So there's no point in having a larger editor, which is basically what the files that he sent us were. So let's go ahead and enter A8, and I want to go around and around in circles and show you all of the different functions without having to type into it continuously. So I'm going to enter verbose as an argument, and I'm going to send that to main. So we can see here verbose mode is active. So now we're inside the student's record system, and let's just go ahead and sort by first name. Awesome. Okay, so we can see here it's sorted everything by first name. That's all in alphabetical order. Multiple Johns, multiple Adams. That's how I found it. Luckily, not multiple Erics, because Eric Jones spells his with a C, whereas I suppose the other Eric is more like Eric. But whoops. So you can see here that it's still prompting us for something else. That's because I sent it under verbose mode, so it's just an infinite loop. It'll continue asking you, great, we just sorted by first. Now what do you want? Let's sort last. Okay, so now you can see that the lists have changed. Now it's sorting everything by last name. Okay, now let's sort by ID. It's an easy one. Done. Okay, now let's try, so we've tried sort. Let's just try print just to show that that works. So let's just say print record, because it has to ask for 2 things. We could technically say, print world, it wouldn't matter. All that it does is it reads the first argument. But if you just try and send it 1 argument, it doesn't really work. So I just say print record sounds official, done, and it prints the record as it originally was. So we can see here that it's different. It's not actually sorted by, or actually it is sorted by ID right now, because that's how we sorted it. But if, for instance, we were to say sort last, done, and then we were to say print record, it would print the latest iteration of the record. So, it works, but it prints whatever the last sort was. So if you wanted the original record, I suppose you'd have to say sort last, because that's how it was originally formatted in the actual file. Okay, so now we're going to try out the search function. So let's search by first name. Okay, so you can see search called. It wouldn't have said that if I hadn't sent it verbose, but verbose uses debugging, so it'll tell me which function I'm in. So it asks for a first name here. Let's do my name. Let's do Austin. Awesome, so it finds it, and it just prints out Austin. Looks like I'm not doing so well. Maybe I shouldn't have